algebra students, Mr. B here. All right, we're still working on trying to find the zeros of polynomial functions. And we know we don't have a whole lot of tools for this. We have the rational zeros theorem. That's probably the most useful. Here's another one that sometimes comes in handy. It's called the irrational zeros theorem. And it goes like this. It says if the polynomial p of x has rational coefficients, meaning there's no roots in the coefficients, you just see integers or fractions for the coefficients, then if you have this irrational zero, a plus b square root of c, then its conjugate will also have to be a zero. So if you have a plus b square root of c as a zero, then you'll have a minus b square root of c as a zero. All right, let's see how this could be put into practice here. Got an example. Let's get this queued up here. All right, so here's our polynomial. You can see that it's fourth degree. X to the fourth is our highest. Our leading term has a power of 4, so it's degree 4. That means we're going to have 4 zeros. They could be repeated, they might be real, some might be non-real. We're actually told that one of the zeros is irrational. It's square root of 3. And they ask, what are the remaining zeros? Maybe you can't see that, hidden by the by my picture there. Anyway, all right. So according to the irrational zeros theorem, which said if we had something like a plus b square root of c, how does square root of 3 fit in this? I imagine that the a must be 0 and the b must be 1. And the theorem says that the conjugate of this should also be a 0, which is 0, not plus, it'd be minus. All right. There we go. 0 minus the 1 square root of 3. So we have plus and minus square root of 3 as zeros. Now, we want to break down this polynomial into its factors. And we now know, since the zeros are square root of 3 and minus square root of 3, that two of the factors would be x minus square root of 3 and x plus square root of 3. We'd like to divide these into this polynomial to find out what the remaining factors are. And we're going to use our old friend synthetic division here. And let's work on square root of 3. So what are our coefficients? I see that we don't need any placeholders. We have 4, 3, 2, 1 for the powers here. We're not missing anything. And notice I'm going to leave a little space here. You'll see why in a minute. 1, negative 1, negative 5, 3, and 6. All right, so we bring the first number down, 1. Then we multiply. We get square root of 3. And we know we can't just add these together because the 1 doesn't have a square root of 3 on it. We keep them separate. We'll have to say this is negative 1 plus square root of 3. All right, and then we multiply by square root of 3. You could do that on the side if you wanted, but let's try to do it in our heads. We know that square root of 3 times the square root of 3 is positive 3, and then square root of 3 times negative 1 would be minus square root of 3. Now we add these numbers. Negative 5 plus 3 is negative 2. We still have this square root, negative 3 subtracting. Okay, now we multiply again. When the square root of 3 multiplies this negative square root of 3, we get negative 3, and then we're going to get minus 2 square root of 3 as well. And then those 3's cancel. We're left with negative 2 square root of 3 when we add this column here. Then we multiply again, and the square root of 3 times square root of 3 is 3. Multiplying by 2 is 6, and there's a minus, so it's negative 6. And just as we were told, it's a 0. We get no remainder when we do the division. That's good. All right, let's keep going. Now, let's divide in the x plus square root of 3 factor. So we'll divide that in by knowing that c is negative square root of 3. Same thing, bring the 1 down, multiply, we get negative square root of 3. Ooh, that's nice, those cancel. We're left with negative 1. Negative square root of 3 times negative 1 is positive square root of 3. Ooh, the square roots go away. We're left with negative 2. Multiply here, we get positive, right? A negative times a negative is positive. 2 square root of 3. And we see we have the same thing in this last column. Add those, you get 0. And now we see that those really were zeros, right? It worked. Okay, so P of x, as far as factoring goes, let's see, where are we in terms of like powers of x? The starting division, this was x to the 4th. This one belonged to x to the 3rd. So this one belongs to x squared. So we have x squared minus x minus 2, that trinomial, and then we have the factors that we know, x minus square root of 3 and x plus square root of 3. And this trinomial factors, right? It factors to x plus 1 and x minus 2, I believe. So we can write out all the factors. There they all are. And now we can identify the zeros. The zeros of this polynomial are negative 1, positive 2, positive square root of 3, and negative square root of 3. All right. Hope that was useful. We'll see you in the next video.